So our formula, which we just figured out, n minus 2 times 180, that's what this theorem says will equal the sum of the interior angles of a polygon. And what you might want to do over to the side, and this is going to be something that holds true for the entire unit, n will always equal the number of sides of your polygon. And in all of our formulas, that's going to hold true. N will stand for the number of sides in our polygon. Now, some people like to take this 180 and distribute it as 180 times n minus 360. I'm not particular about which one you use because they're the same thing. Just one has the 180 distributed, one doesn't. So if you think this one's easier for you to know, then do that one. If you want to do this one, then do the top one. I'm really not going to be picky about which form it's in, as long as you know one of them. So the types of questions that you're going to have to use this theorem will be like, what is the sum of the interior angles of a heptagon? So start off with how many sides are in a heptagon? 7. So n is going to equal 7. So 7 minus 2 times 180. So that would give us 5 times 180. So 900 degrees would be our sum. We are also sometimes asked to use the same formula going backwards. And what I mean by going backwards is they tell us that the sum of the interior angles in a polygon are 1,980 degrees. How many sides? Does it have? So this is what I mean by backwards. It's going to give us 80, yes. It's going to give us the sum, and we have to solve for n, the number of sides. So since we don't know what n is, we're just going to leave the formula like it is. But we know that it has to equal 1,980. So from here we get to solve for n. Anyone know how they would start this for solving for n? William?
1980 divided by 180.
Okay, one way to start this is to divide both sides by 180 right away. So you get n minus 2 equals, and let's see, those will cancel out, 11. What can we do then to solve for n? Add 2, and we get that it has 13 sides. Now, Reagan, you had your hand up. Were you going to start us off the same way?
Yeah.
Okay. If you don't see the dividing first, you could always distribute the 180 and turn it into this and then solve. That works as well. You get the same answer. You just might have some slightly bigger numbers to deal with, but it still works out the same way. Okay, these are the two ways that you're going to be using that first formula, the n minus 2 times 180. And if you want, you can even put a little note to yourself, number 1 to 3 on your homework is using this formula. Okay? So any questions on this formula at this point in time? Okay, so the next thing we're going to do is we're going to build on this formula to make another one. I've thrown around during the activity the word regular polygon. Anyone think they know what a regular polygon is compared to just a polygon? So putting that word regular in front changes something, or it tells us something. A regular, well, William, were you going to take a guess?
Yeah, maybe.
What do you think?
A polygon has, like an octagon has 8 sides.
Mm-hmm.
But sometimes like less jar and you can't get them all to be equal. And maybe a regular polygon makes them all equal.
You're really close. Okay, that word equal is what's really close. Adam?
Aren't they like called like they could be like called like stars or like the one with these like a convex and it's like all the angles are like it's like there's like a big word. It's like
Equilateral and equiangular.
Equiangular. Yeah.
Okay, so stars are not regular polygons because those are concave. But a regular polygon is like a square when all sides and all angles are congruent. So in a square we have 4 equal sides and we have all right angles, making it a regular quadrilateral. For a triangle, that would be an equilateral triangle because all the angles are 60 and all the sides are the same. So when we have this situation where we have regular polygons, we can find the measure of one angle because we know they're all the same, right? So if I wanted to find what is the measure of one, keyword one, angle in a regular, that's our other keyword, regular nonagon. Throwing a new one at you. So the key words for this one are one angle and regular. If we want to know one angle, we first have to know what all the angles equal. Okay, so we're going to start by finding out what is the sum of all the angles. And then we're going to divide it by the number of sides, and that will give us 1. And the reason this works with regular polygons is because we know all of the angles are the same. If it's not regular, this will not work. This only works when it's regular. So if we use our formula for sum and then put it over n, this is our formula for one angle in a regular polygon. So to actually answer this question, nonagon, how many sides do you think that has? 8 is octa. 10 is deca. 9. 9 is what this one stands for. So here, nonagon, it has 9 sides. So when we plug it into the formula, we'll have 9 minus 2 times 180 divided by 9. So 7 times 180 divided by 9. 1,260 divided by 9. and that'll give us 140 degrees for each angle on the inside. Okay, and again, if you want to make yourself a little note, you're using this formula on numbers 4 through 6 of your homework. So when you're going through and it's asking you what's the measure of one angle of a regular polygon, you're going to be using this one where we do our sum and then divide it by n. William, what's up?
I was going to say for, when you're finding like, one of the angles, can you go to like 90 degrees and then add like, I forgot how to like, add like 10 for every
So you're trying to come up with like a quick way to do it in your head?
yeah.
Okay. Well, when you think of one, run it by me and I'll let you know.
Okay.
Because there might be, I don't know of, these are the two quickest ways I know of, and it's just doing fast math in my head that gets me there. But if you think of one that you think might work, let me know. I'd be curious to hear it. All right, so any questions so far? So we've taken the same formula, which is the top here, and we've just added a divided by n to find a single angle of a regular polygon. That's our second formula. So we only have like 3 for this whole chapter. 1 was this one. 2 is this one right here. And then our third one has to deal with the exterior angle. So our next formula or topic is exterior angles. So in a triangle, we've already dealt a little bit with exterior angles on triangles when we did our exterior angle theorem. But we can have exterior angles on any shape, as long as it's outside of our figure, or it's one of our sides extended outside the figure. There's something special about the exterior angles in a polygon. One thing we know is that the exterior plus the interior will always add up to 180 because they make a straight line. But there's something special about the sum of the exterior angles. So we have a formula for interior, but exterior, we don't really have a formula because it always equals the same number no matter how many sides you have. Your exterior angles are going to always be 360. Okay, so this is a test question, and it's a trick one because everyone seems to try to think of a formula. Your question's going to say, the sum of the exterior angles of an octagon are A, something, B, something, C, something, D, something. One of those somethings will say 360. But if you try to use a formula, those answers are going to be there too. So you will have a question that says, what is the sum of the exterior angles of a shape? Just go straight to 360, circle it, and be done. Okay, I'm giving you an answer to the test right now. Just don't fall victim to reading too fast. Okay. So when we actually see problems that use exterior angles or use this idea, find the measure of an exterior angle of a regular 36-sided polygon. Okay, so 36 gone. That's whenever we don't have a special name for it, like quadrilateral is a special name for a 4-sided polygon. So when we don't have a special name for it, we just put the number of sides, dash, gone. That's how we write the polygon. So this is saying find the measure of an exterior angle of a regular 36-sided polygon. Now something I don't think I put up here that I should have is if it's a regular polygon, what do you we know that that means all the inside angles are the same. What do you think it means about the exterior? They're also all the same. So we can take what we know our sum is, 360, and divide it evenly by the number of sides, by n, and that'll give us the measure of one angle, or one exterior angle. So each angle on the outside will be 10 degrees. This is what you're going to be doing on, is it numbers 10 through 12. You guys are going to be finding exterior angles. So if you want to write a note for yourself, this is what you're doing on numbers 10 through 12. Okay, those are your 3 formulas that you're working with tonight. Are there any questions or clarifications on any of those formulas? Okay, I want to do one more with you guys, and this one's actually in your homework assignment. So flip the page open, so go to the back page of the activity we just did. Go to number 7. I'm going to write it up here. You guys have it on your paper already. Okay, our directions here are to find the missing angle measures. Does anyone think they might know how you do this?
Yes. Wait, these 3 columns. So, I mean, include 2x equals. Oh, wait, no, 2x plus 20 equals 180.
Okay, right idea, wrong numbers. Right idea, wrong numbers. Matt?
2x plus 20 plus 2x plus 20 is equal to 2x plus 2x.
Can we just say 4x plus 20?
So, hold on, time out. So you're saying add these 2 together and it'll equal these 2?
Yeah.
Nope. What were you going to adjust yours, Serena? I see you, Adam. You're coming next.
4x plus 20 equals 180.
Okay, so 4x plus 20 equals 180. Almost. Adam, what were you going to say?
Could you do 4x plus 40 plus 4x equals
360. Okay, so take what we did with triangles. Yes, you're right, Adam. So take what we did with the triangles, how we add up all the angles and set it equal to 180. Same thing, we're going to add up all the angles, but this time we set it equal to 360 because that's what a quadrilateral is supposed to add up to. So it's the same idea, and if you look at 8 and 9, those are pentagons. So you're going to do the same thing where you add up all your angles and set it equal to whatever the sum is supposed to equal. So if we add up our 2 x's, we get 4x. Add these 2 together, we get 4x plus 80, or sorry, plus 40. And they have to add up to 360. Combine like terms. Move the 40 to the other side. and then divide by 8, and we get x is 40. So on 7, 8, and 9, along with 13, 14, and 15, you're going to be using the same idea that we did with triangles, but they're not necessarily going to equal 180 anymore. You have to figure out what they're going to equal based on the number of sides in your shape. Okay, but this wasn't asking for x. What was it asking for?
Find the missing angle.
We have to go plug it back in and find the missing angle. So 2 times 40, that means these are 80. 2 times 40 plus 20, that means these are 100. Okay, that's what you're going to do for 7, 8, and 9, as well as 13, 14, and 15. Is you're going to be taking it based on a picture or a diagram, making sure you look at the number of sides so you add them to equal the right thing. Okay, any questions on 7 and how you would do those? Okay, can you look at 13 for me? What shape do you see on 13? Oops.
Equilateral. Or quadrilateral.
Look at your paper, not my drawing. I'm sketching. So, what shape is that? We haven't learned that yet. It's a quadrilateral, but it is a specific thing called a trapezoid, which we are learning about this chapter. We're learning about it a little later. Okay, sorry, I didn't mean to draw this extra piece over here. Okay, so this one, we're just going to talk through how to solve it. So quadrilateral, what do I know about the angles inside here? They add up to 360, so I'm going to add them together, set it equal to 360. That'll help us find x. But what can we do to find y? Katie?
Do 180 minus x.
We'll take 180 and subtract whatever we get for x, and that'll equal y, because x and y are a linear pair. That's an idea that you're going to use on 13 and 14. Now 15, I also want to look at, just to kind of make sure you all understand what is being asked of you. Nope, that's backwards. Okay, 15, you have something that looks like this, but your inside angles are all variables. But your outside angles also have variables. Anyone have a thought as to how you might go about starting this one? Serena?
So, I mean, never mind.
Never mind. Ria?
Z minus 13, plus C plus 10, plus C equals
360?
360.
Yeah. Okay, so because we don't know anything about the inside angles, and we have all three exterior angles, we're going to use the fact that exterior add up to 360. So this would be one where you start with the exterior and work your way interior. So that's how 13 and 14 differ from 15. Adam?
When you're setting it up, can you do 3z instead of writing all that out, or do you have to write all that out?
If you want to start by just combining like terms and doing 3z minus 3 and then equals 360, that's fine. I just need to see some sort of equation, not just an answer. Okay, so real quick, I want you guys to look at 16, 17, and 18. What do you notice? It gives you a measurement. What do you notice about the measurements for 16, 17, and 18? They're all the same. That's a typo. So we're going to fix that right now. Number 17, change it to 120 degrees. And for number 18, change it to 18 degrees. That way you're doing three separate degree values. So sorry about that. These are new worksheets. I didn't catch the typo in time. Okay, so your homework tonight that's due on Monday is this worksheet, 5-1. So make sure you guys have it ready to go by Monday, because we'll turn it in on Monday. Also, your class